All right. Uh, this is the weekly API meeting work stream discussion. I wanted to go ahead and get things kicked off. We got several things I think to cover today. The first one is Mercedes put together an IPsec demo, which we want to start off with that, and then we'll continue on the Kubernetes and CNI discussion. We've had a couple of contributions there. Marianne is put out a contribution to that, which we've also uploaded to the site, and we've also got a contribution that's come in from Tashi. So at this point, I'm going to turn it over to Mercedes so that he can kind of go through the demo with us, and then once that's complete, we'll start into the Kubernetes and CNI discussion.
Sure. Thank you very much. So this is about the security APIs, which are already there. And this is based mostly on a discussion from, I think, 2-3 meetings ago about, practical application and things that are already done and working into OPI. So not just defining the API, but actually having code that works. In this demo, what I'm going to use mostly, I'll show IPsec get version stats, load the connection, list connection, and do full list. I'm not going to use initiate, terminate, rekey, and unload connection from the APIs available, although those I tried. In this demo, the IPsec endpoint will be the responder, not the initiator. So once the connections are loaded, it will start responding. So these are the API, and the APIs, the proto file can be found here for these APIs. Testbed-wise, a server with a DPU in it. And for traffic generation, I have 2 ports from our hardware, but it's not needed. We'll see it in the diagram. Now, in terms of test topology, what do I have? So I have the server, like I showed there, with a SmartNIC. It's running IPsec with full hardware offload. Strong Swan is the IPsec, interface, the software portion. And then on top of it, we have the OPI security server. And then I have a Python script. I don't know, I call it security controller here. It's somebody will have to give and program via the OPI interface all these tunnels, add them, remove them, do whatever. And then from the traffic-wise, what I have an IPsec initiator that goes into the DPU. I configure 2 tunnels. And then I have on another interface unencrypted, an HTTP server, and then I have some HTTP clients that are sending requests to the server, and the server will reply. And this will also validate in a way that traffic gets encrypted, gets decrypted. This guy responds and goes back through the process. This is an encrypted portion of the traffic. Now, how this could be realized also on the DPU, I can enable the virtual functions towards the operating system on that machine, and I could have this portion directly on the host. Probably this is how it's usually done, but for demo purposes, this works as well. All right, so now moving directly into the demo, what do I have here? One, I'll just start the logging on Strong Swan. The other one, this is starting the OPI security server that will be listening for the API gRPC calls. This logging here and this OPI API server are running on the DPU directly. And this is another machine. This is a totally different machine where I just clone the OPI API security, and I got the Python bindings. I think there are Go bindings, and for some other APIs, also other languages as well. I think there is a C binding as well present. And with this in mind.
Hey, Marcia, quick question.
Yes.
The server that is running on the right side, is that part of the PR you submitted?
This is already present. OPI security server, it's already the container and everything. It's already uploaded here. It's being built. It already exists.
Got it. Thanks. Yeah.
Yeah, so
We developed that VPN as part of OPI.
Yeah, definitely. I think it's in different repo. I'll go over it. Thanks. Yeah.
So I just started the container, like I said, the container it's already built, it's already provided by OPI. I did not have to do anything here. Maybe the only cheating will be that I don't think the DPU had Docker running on it. So I think I had to install Docker by myself. But other than that, I just started the container. So now what we do here, basically, if we do IPsec get version, this is OPI API. It's responding whatever it's in there. We can even see the DPU name. This is some other stuff, some stats. Doesn't come quite nicely formatted, but you know, it gets the information going through. And we see also something happening here. And now once we start creating the tunnels, let's go over this. These are more. These have a lot of things in them and calls and objects which are being created for local addresses, the children and everything, and the keys, the proposals. But now when we do it, and let's get through the next one. Give me 1 second. This we have the config for the 2 tunnels, and now we're gonna load them. Let's load one by one. We can see how swanctl detected 1 tunnel coming through. We can see the log in the OPI API server coming for the object which you are creating. Now, usually when you run it, I'm running it like this with interactive, so we can see the log and something that happens. You know, if you actually run it in production, probably will run it detached and decouple. And the second one, so we have both, and now just let me start. Basically, this will initiate the IPsec tunnels from the other side. And we should be able to see in the logs now, the Strongson logs, how the IPsec tunnels are being created. I mean, there he's responding, the tunnels are already there. And traffic will go through and everything will work. But I mean, the demo is mostly for the API portion. Well, that is going. They're like, we can use it to list the connections, and we can see what we have configured there. This is okay, I see this is done something. I think this is empty. There was nothing there at this moment. And let's see if certificate. I guess there is no certificate either. So going back to this, these are the APIs. Like I said, it's already working. All I had to do was to download the container and start it. And then I just created a Python script, basically, that I put in a PR also in a demo folder, loading the OPI API Python bindings in this case, and then just using them. And let's see if, yeah, okay. So we see how we start initiating the IPsec tunnel, everything got negotiated, and I think, yeah, we can see both clients sending traffic, doing connections and so on, and server responding to them. So it's also doing the encryption and decryption and everything. Now, the usual use cases for IPsec, mostly that I'm used with, I have one usually for telecom, where it's actually doing millions of tunnels and a lot of initiating, terminating, and they keep going all over the place. And it matters a lot to have tunnels per second, like rate capabilities. And I think this is a great use of DPUs to offload that. And then the enterprise use case usually where it's sometimes site to site, and you want, I mean, you have less number of tunnels, but then you have a lot of throughput going through them. But for API perspective, I think the API will be able to do both. Okay, that was it. Showing it that, I don't know, I can take the OPI containers that already exist and the Python bindings that already exist and actually run IPsec traffic through a DPU.
All right. Thank you, Mircea. Any questions?
I have a few comments before we go to question. So
Sure.
one thing that I think will be useful, and maybe I can help with that too, to get these bindings. Like I think Python has PyPy, and I don't know if Go has also a repository. I don't know if those APIs are yet pushed, so I don't have to clone the repo and get those files from there. We can just do, I don't know, pip install OPI, and then you do opi.security.blah, and it's much easier if we can push upstream in PyPy, basically the packages. I think Go has a similar thing. So that's one, to feedback that would have helped me. And the other one, I don't know if we want to start creating, or maybe this is vendors, images for the DPUs that have this, because see, I downloaded the container and works. I made it work, but this is not quite, I'll say, production ready maybe. I mean, you want this container to be started automatically when the DPU boots and have this API endpoint already present there. And maybe you don't want only IPsec. Maybe you want also the storage and all the other API endpoints in one. Present on the DPU, and if it crashes or something happens, you want to automatically be restarted so people don't even realize anything happened. So I think vendors will have to do a bit of packaging to actually provide the support and, OPI enabled images or something. So one
question.
Yeah.
Interesting, Carol speaking. The container, is that tailored to that your particular DPU, or is that generic? There was a proposal by where you actually used the tunnel API to create the actual IPsec tunnels. Is that used in the container?
So it is, let me answer. It is generic, but now, the asterisk on it. I believe it's provided for x86 ARM, and I don't know if there is any other architecture, Boris. I think there are like 2 or 3 architecture of CPU. So now if your DPU has MIPS or something there, I don't know, some other core may not work. And then it uses as a IPsec engine StrongSwan. So if your IPsec software or engine, whatever, is not StrongSwan, then it will not be able to interface with whatever other IPsec thing you're using there. I don't know if there is anything else available, but so there are 2 things. One, your cores on your DPU needs to be x86 ARM, and I think there is another one supported, if I'm not mistaken. And second, you need to run StrongSwan on the DPU. If you don't run StrongSwan, then
yeah. But StrongSwan has a plugin architecture, and there's a plugin. Would that be tailored to the particularly DPU? Because I mean, the different DPUs do the encryption probably in different ways, and there must be somewhere where it's adapted.
Yeah, let me answer, Jens. Yeah, so good question, right? So what we see today is we see most of the DPU vendors have plugins for StrongSwan for their specific hardware accelerators. Okay, so this is why we created this gRPC API on top of StrongSwan, so we can send gRPC APIs through the StrongSwan, and then private plugins will be used for StrongSwan to actual hardware offloads. Make sense?
Yes, that makes sense. But it's not supposed to use the tunnel API for southbound of StrongSwan. It's dedicated plugin for the particular DPU.
No, it's generic across all the DPU vendors that run StrongSwan.
Yeah.
And if some DPU that cannot or don't want to run strong swan and do a plugin for that, because what we defined is gRPC protobuf APIs, they can implement directly the gRPC protobuf APIs. I believe that AMD Pensando did exactly that. So they have gRPC APIs that you can send directly to them. So from the customer perspective who is sending those APIs, he doesn't care if a strong swan is running on the DPUs or you have FPGA, P4 pipeline, whatever based system without strong swan. From customer perspective, it's absolutely agnostic. He's using those gRPC APIs that Mircea is showing on the screen.
Right.
That's fine. I mean, these APIs, the northbound of StrongSwan is very convenient and so on. So, and the southbound interface seems to be sort of tailored to having different plugins for StrongSwan, if I get it right.
Yeah, and this is what we see. We see different DPU vendors implement plugins in the StrongSwan system for their specific hardware accelerators, and we welcome that very much and don't want to intervene with that too much. I think that's a good direction for them. And if we have StrongSwan on top of that, then we can abstract using those APIs. And for those who don't have, like Vipin, you were saying something, go ahead.
No, I think your observation is correct, Boris. So I think the commonality really resides at the OPI layer, which is what the standardization layer is. And people could have crazy kind of integration with StrongSwan or choose something else that they feel is comfortable for their hardware capabilities.
Agree, but because we identify that most of the DPU vendors are using StrongSwan and have plugins for their hardware accelerators, we felt as OPI community a need to actually implement those API implementation to StrongSwan with specific plugins for different DPU vendors, so we can actually showcase and demo and actually have something that is up and running. Once Vipin, you ramp up with AMD Pensando demo using those APIs, we can definitely showcase and add it to that, which will be a different use of the same APIs without StrongSwan running on the DPU itself.
Makes very much sense, but the only, when I got confused was that in one of the drawings on the seems to be the tunnel APIs, the tunnel offload API seem to be in play, and that's a little bit confusing. But now
I agree with you, Jens. So what we initially created is we kind of mixed between the session offload and the IPsec, and I requested Kyle to split it. So we did a split, and we have now clean IPsec APIs separately from the session offload and tunnel offload APIs. They live in a different repository and provide a different container. We can absolutely combine them in a single solution, but just in order to make a progress and to have this demo very much contained to itself, this is why we're only focusing on IPsec. Once we have another demo with tunnel offload and session offload, we can do that demo, and then we can combine two demos together and do overall demo. So the drawings that you see, maybe it's oversight from that split that we made just to make a progress. That's why you see that.
Thanks for the explanation. That's helpful up.
Okay, that's
And
all from my side.
Paul will update the demo to the demo folder on our YouTube channel. We now started a new list of all the demos that we're doing, so it will be a demo available there. Look forward for it.
Okay, great. Thank you, Mircea. That was good. The next area that we want to go back into is our Kubernetes and CNI discussion that we were doing last week. I know that Marianne and Tashi have made some contributions around that. There's a couple PDFs that we've uploaded into the doc section of the API work group. So Marianne or Tashi, go through these with the team today. I think it might be good if we walk through them, let people take a look who haven't looked at it yet and ask any questions at this point, or at least you can give an overview of them also.
Yeah, sorry, folks. Billy and Donald are actually going to present. It's a joint effort across all three of us.
Okay,
Yeah.
that would be great.
Donald, did you want me to share? Or are you sharing, or where do we stand there? All right, I guess I will share then.
Sorry, I was on mute there, Billy. I was saying you can share if you're ready. Otherwise, I'm ready to.
Yeah, no worries. Let me, there's a presentation mode somewhere. I missed it. I saw it. Present, there we go. All right. Yeah, so this was joined between a couple of us at Red Hat, and one of the things that I assume everyone can see my screen okay?
Yes, looks good.
So in some previous discussions, I feel like we kind of felt like we were talking about different scenarios. So one person was talking about scenario A and some person was talking about scenario B, and they're trying to talk about an API, and they were missing each other because we're talking about two different scenarios. And so we thought that if we could kind of nail down, what it is that we want to support, then we can start focusing down on the APIs themselves a little more focused. And so we came up with this. Let's see, where are we here? So this is without DPUs, just kind of giving an overview. We do want to point out that kind of some of our drawings that we have are all logical models. I don't want to get too in the details of, well, my arrows, my boxes are all going through this networking pods, as we're calling them, and for this discussion, we're really kind of saying, well, you've got the CNI setting up some network, and when I tried to draw them separate, it got too confusing and too crazy. So we just kind of have this block where you've got the CNI setting up the networking. So these are logical models. Don't get too hung up on errors coming into a pod when they're not necessarily supposed to be, especially with the infrastructure networking. And so these are all Kubernetes. We can talk about more generically, but what we are focusing on was Kubernetes at this point. So these are all supposed to be represent some Kubernetes deployment scenarios.
So Billy, does the CNI there live in the purple?
Yes, that's kind of the thought. Yes. All right, Donald, you want to talk about some of the actors and use cases?
Yeah, so it's kind of the other thing that became apparent in the previous discussions is that not only are there different APIs, but there are different consumers of those APIs across the system. And the style of API is probably going to be related to the role of actor that wants to consume that API. And so just as a kind of first pass, we started to identify the infrastructure admin actor, the CNI as an actor that wants to use APIs, and also potentially CNFs that get deployed onto the DPU to extend capabilities that are available for pipeline processing, may also be an actor that wants to use some APIs. And then beyond that, we started to identify kind of different subsets of networking API, which are admin operations, service style operations, and network style operations. And so here we've tried to just kind of group together some fairly high level use cases.
Sorry to interrupt, right? Sorry to interrupt. There's some parts on the screen that are missing. I think it's getting cut off on the right side.
Okay.
As we're recording, it may be useful to have that.
Not sure.
Not sure.
Yeah,
that's fine. That's fine.
You have to leave presentation mode in order to do that.
Yeah.
Okay.
Yeah, this is better. We can go with this. Thank you.
Okay.
Yeah, so we've then just identified some fairly high level use cases that each of these actors would be typically carrying out. So for example, the infra admin needs to initially to be able to configure DPU networking. In the case kind of outlined in the diagram that Billy showed earlier, and we'll go into it in the scenarios later. We may well be deploying CNI infra pods on the DPU. That's an admin function. And if we're extending the infrastructure capabilities, we may be wanting to deploy a CNF, such as a firewall or something like that, onto the DPU as well. So
why
then
do you-
below
why-
that,
Excuse me,
sorry.
why do you distinguish between a pod and a CNF? Aren't they both containerized workloads?
Sorry, I don't quite follow the question.
You have a column there of stuff dealing with pods, deploy infra pods. You have a separate one called deploy CNFs. And I don't understand
yeah,
the distinction between a pod and a CNF.
So don't read too much into the word pod being there or not being there. The infra is really saying that we're deploying CNI infra, and CNF is saying that we're wanting to add additional third-party capabilities, is really what we're saying here. And if it's helpful to clean up some of the terminology, then that's something we can go back and do. And really the distinction between the middle column and the right-hand column, I would say, is that we perceive the right-hand piece as being a dynamic use case, where for the middle case, we've probably already got an existing API set in the admin API provided by OPI. But when a vendor third-party CNF gets added, then they may well want to publish an additional section of or extension API that covers those additional CNF features. And so the interesting thing that comes out of that is that the infra APIs need to be dynamically extensible, and the client, the consumer of those, needs to be able to query and discover additional APIs and features that have been enabled on the system. And then below that, so these are all kind of external consumer admin interfaces in that pink dot. And then in the green APIs, we're perceiving more as lower level APIs for talking directly to or an abstraction above the vendor implementations to actually configure features. Okay, thanks, Billy. Next one. So that was infrastructure lifecycle use cases, and here we're more thinking about pod lifecycle use cases. And on the left-hand side, we've got an app that wants to directly consume some kind of encryption offload. So that may be TLS offload or something like that, which we're calling a service API, because there's some kind of offload being provided by the DPU that an app pod running on the host wants to consume directly. And then the other use cases are, once we have CNI running on the DPU infrastructure, then we want to be able to configure the features that CNI needs. So configuring pod VFs, configuring policies, and then implementing offload accelerations. So these seem to be the API points that we need from a network API perspective. And then we'll start to see how these come about in some of the scenarios that we're going to cover in the following diagrams. Any questions on the actors, or we'll move ahead to the scenarios with Billy?
It's all very clear. Thanks, Don.
Okay, so I do want to point out, so we've got 5 scenarios here. These are just, we want these as talking points so everyone's on the same page, so that when we start talking about APIs and we bring up a certain, we can say, well, in scenario 1, we may not support it, but this is what would be happening. So, these are just mainly, we just want to kind of get into some talking points so that everyone is on the same page when we're discussing some of these things. So for scenario 1, what we're thinking here is, an example would be, we want to offload the Kubernetes infrastructure networking down to the DPU. We kind of call this more of a brownfield. You've got a bunch, Vipin and us have talked a couple times about all these existing CNIs, and we'll have to go in and change a bunch of code to make those work, or do we not? And how do we make that work? So the thought here is there may be some existing CNIs. You know, I could use Cilium, for example. We want maybe one to enable it to run on a DPU, but at least initially it may not take advantage of any of the hardware acceleration. Cilium strongly leverages eBPF, and to try to model a bunch of eBPF calls through an API just may be impossible. So it may be worthwhile just to say, well, you know what, we still gain benefit by being able to run some of these infrastructure pods down on the DPU. You've got the security that we've talked about before. You've got the CPU offload from the host, and this is where the, you know, the pods are being plumbed together, so it needs to run down on the DPU. So our first example is really just a brownfield, just taking the existing CNI, for example, and just running it on the DPU. There may be some acceleration as time goes on, where we find different pockets that you can accelerate. So also with these, we tried to say, you know, what is the OPI API in this picture? In this one, there may be minimal. You know, opens in my mind are for something generic like this. How do the interfaces get exposed up to the host, and are they selected, and how are they selected and mapped into the pods? Is that something that OPI needs to cover, or is that something, you know, is it the OPI API? Or I've only been to one or two of the provisioning life cycle, but, you know, how are these interfaces exposed? Is that really a life cycle and provisioning function, or is that something within OPI API that we need to cover? So any comments on the
Really,
first scenario?
I do have one comment. I think this is very interesting breakdown you guys have put together. For this scenario, there are two aspects to it. The first one is creating those VFs, PFs, and interfaces that plugs into the pod, which could be arguably part of life cycle or some initial configuration on how a device should look like. So this is more devicey thing rather than networking stuff. And then there is this networking part, which is like which pod is associated with which VF or which interface. And that needs to be communicated from host into the CNI, supposedly, which is running on the card or DPU. So that association part, I mean, typically a CNI does that running on the host where pods are getting deployed, and it intercepts that. And this could be maybe 100, 200 lines of code, which just says, okay, I have these all VFs or interfaces available. I'm going to pick this VF and assign to this pod and communicate that to DPU. But that part is more networky, and the previous part is more, this is my observation. I don't know what you guys think about it.
Right. And that was kind of my thinking too. The initial, how many VFs are we exposing? That's kind of, that to me, that's day zero, you know, setting up the hardware. That sounds more like provisioning and lifecycle. I know, well, in the past, if you were to use something like the SROV device plugin, you know, actually, they don't actually get to choose which interfaces get used. It's the device, it's Kubelet that tells the device plugin or the CNI, this is the interface, the VF of the one that you gave me to use. And so how do we get that information down? Is that a function of the, you know, we may want to go through a Kube API to do it, but do we need to define how that happens? You know, these are kind of questions. These are, you know, as we're going through, you know, how does that information get dropped down? I'm not saying how we should do it. These are just things that we should start thinking about.
Agreed. But if you keep the if you keep the personas that you described just above, like it is infra-admin and there is Kube APIs, you could argue that there is infra-admin that is also controlling these details through Kube APIs. Mm-hmm. But if you want that to be decoupled from a DevOps person who is managing pods and all that, then maybe not have to specify the VFs to pod association right through the Kube APIs to some extension. So either way works. I'm just saying that, you know, it goes back into the personas that you try to describe in the first slide as to what role you know, different entities have and what would be the right thing for an infrastructure provider in this case.
Right. And then the last point here is, you know, I was just talking VFs, but, you know, some vendors may have sub-functions, scalable functions. There may be something else that we haven't thought of yet that's coming down the pipe that y'all know about, I don't know about, that isn't any of those. How do we model these interfaces so that they're generic enough that we don't have to rework everything when this new type comes out. I mean, and how it gets plumbed into a pod, just, you know, brainstorming thoughts there. So,
So Billy, I have a question or a couple.
Yeah.
So in this use case, does the pod to pod traffic go through the DPU?
that was my thought. And I think that was kind of, at least my opinion, that's how most of the DPUs would work. And if not, then maybe that's something we need to figure out.
And that would include even local host?
Yeah, if it's going pod to pod. Yeah, now a local host to a local host may not, depends on how you've implemented your host networking. But yes, I was assuming like in this drawing where pod 4 talks to pod 5, it could potentially go through the DPU. Now that's something we need to discuss. Do we say that we want local traffic to be managed on the host only and not on the DPU? I think these are things we need to talk about.
Yeah, I mean, logically, if we move the CNI to the DPU, then all the networking traffic from a pod needs to go through that CNI.
Right, right. And that was my vision, but I mean, I'm glad you brought that up because other people may not be talking that, and we need to make sure everyone's on the same page when we start talking about stuff like this. So
we are offloading the network policy to the XPU, and we need to basically use the local pod-to-pod traffic to go through the XPU.
Yeah, even I would double that, Toshi, what Toshi is saying, and what I think has been discussed. Pod to pod must go through DPU because otherwise the security construct is out of the window. Even pod to host should be through DPU because why give host access to a pod that is not supposed to be talking on certain ports and whatnot? So just from security posture, if you're creating a construct whereby the security control point resides on the DPU, or rather is configured through API on a DPU, then let it be going through host.
Yeah, and you could argue if all the traffic's going through the DPU, then that's a great point to insert telemetry because you can see everything.
Correct.
I mean, I think that I think that's the way it should work, but I don't want to make assumptions. I think some things like this we need to make sure we capture somewhere.
Yeah, so somewhat simplistically then, each of those pods would get a VF rather than a VETH. And you could would it be right to view the on the host, you need some kind of shim CNI that is all it's responsible for is allocating the VF and then communicating to the DPU what VF the pod's been allocated?
That would be ideal, Don, because that way I think we can reduce the footprint, but not just from CPU point of view, but technically that CNI should never have to change, and we can decouple the CNI upgrades and CNI functionality from the host OS and server function quite plainly.
Assuming we have a driver, right, to talk over the PCI bus to the DPU, where does that driver reside?
This is the NIC driver you're saying? Yeah, that has to be on the host. I'm assuming that most of the drivers from all DP vendors are upstreamed on any Linux kernel, so we should be good there, right? We don't need to install anything new there.
What was the question? I want to make sure. Repeat the question again.
Is the driver functionality in the OS on the host?
I mean, yeah, I mean, I would agree with what Vipin said, but what was the reasoning for it? What was there was a part before that I wanted to make sure I caught. Or maybe there wasn't.
My question was, I mean, normally a container doesn't have a driver in it, right? It relies on the CNI for the driver to go across the bus. So where does that driver reside? That's my question. And I think Vipin's saying it's in the Linux kernel of the host.
Of the host.
Yeah, I think it goes back to the point, maybe I thought, Tim, your question was alluding to, do we need to really install anything different on the host? So I'm suggesting that with a standard upstream Linux kernel based distro and this mini 200 lines of CNI code or small code, which is running on the host, you can practically make all DPUs implement the OPI APIs to offload these things.
Right? So you could have a CNI shim essentially. That's
correct.
Yeah.
Correct. Yeah. In fact, to be honest, we toyed around implementing that. It's not that big of a deal, so we could easily do that.
Yeah, I would like to, and maybe this isn't the call for that. I think that's something that either the next topic, if we get to it, or if not next week, about the CNI, and maybe we'll go into deeper detail about that shim. because I want to make sure I understand we're on the same page there too. One question I didn't quite see if anyone asked, or if it was if we had multiple host network pods, like I had a pod 8 sitting on the host. I'm not sure if pod 7 to pod 8 on the host, if that goes through the DPU or not, because of it being host networked. If a host pod 7 needs to talk to pod 4, then it would go through the DPU. But a pod 8 that's not drawn, that is also host networked, I believe they would talk directly to each other because of just being host networked.
Yeah. If a pod is host network, then technically it's not using the CNI. You're basically
Right.
saying you're
It's
just
out of the
keeping-
picture in
from
that.
networking point of view, network namespace is same as that of host. So you really don't want it to be using CNI in that
Yes.
case.
And that's what I thought. That's what my opinion too. I just want to
it
make, I
makes
thought I
sense.
heard someone, when someone said someone to talk into something, I wanted to make sure that that wasn't assumed.
Yeah, but a pod that is using the CNI, if that has to talk to host, then that we are saying is going to DPU in this picture.
Right. I agree.
Makes sense.
Okay. All right. Should I move on, or do we have more questions here, or?
I have a quick question. Maybe it's basic. So on the storage side, I understood if you have some kind of remote storage, the DPU abstracted all that and provided an interface to a local host where you could look at as virtual, as if it looks as if it is local, right? So I'm just trying to compare that with this. Are we saying that you have offloaded offloaded your network infrastructure into DPU so that the host now, I mean, the DPU will expose, few, for lack of better way of saying, virtual interfaces, and everything else remains same? Or is there anything about CNI Kubernetes I need to think about? It's like that uplink that on the DPU you have, that's the one, imagine that's a physical, and then you somehow manage to make it into 4 virtual interfaces on the host, and host need not worry about anything else. Is that it? Or is there something else I need to go look and about CNIs and pods and things like that?
So if someone knows better, I'll let them speak up. I think that you're just exposing your virtual functions, your VFs, up into the host. And so from, a lot of CNIs that when they're running on the host themselves, they may expose like a VETH pair. This is kind of like a hardware version of VETH pair being exposed up to the host. But if someone has a better answer, from a vendor point of view.
Yes, but then there's a whole bunch of Kubernetes network policy configurations, things that would happen that have to happen out of band. Essentially, they don't get configured on the virtual interface in the host. They need to get configured by the CNI running on the DPU. So
Right. So all your policy and stuff is still being handled down on the DPU.
Yeah. To the point of, is there something Kubernetes CNI that I need to understand? Yes, that's the piece that we need to drill into and understand, is that all of the networking infra configuration for each of those pods happens in the infra running on the DPU.
Okay, got it. So there is a layer on top of the basic infrastructure that gets exposed, and that Kubernetes CNI, all that is that one more layer on top is done on the DPU. Yeah, thank you.
I like the analogy Bill pointed out. This is like a hardware VETH pair, basically. So instead of having 2 tentacles, the tentacle dropping back into Linux kernel, here it's dropping back into the data path DPU.
Yeah.
Okay, so that's scenario 1. We called it brownfield, called it existing CNIs, just running down on the DPU. Probably minimal, but there's still a whole lot of orchestration within Kubernetes we got to figure out. So if we decide that this is something that's needs to be worked out, there's still a lot to do here, even though it's not necessarily a lot of OPI, API definition at that point.
It's also worth mentioning this is probably a prerequisite for some of the other scenarios, but we'll see that as we go through them.
All right.
Billy, a quick request. While you're going through these scenarios, if you can highlight what is the OPI API going to look like? So what is the conclusion from scenario one? What would be the role of OPI API in this one? I know you're showing this admin OPI API, but like, would that be pairing or?
So
Well,
I think
that was kind of the open question. For
Okay.
me, in my opinion, it was minimal OPI API as far as provisioning. But within OPI, I think I kind of pointed out is, how do these get exposed? Do we need to describe that? Is that part of us? These are open questions. Is OPI API need to define how this works? Or do we just give a best practice? Hey, we've thought this through. This is a way you could do it. You don't have to do it this way, but some of us are trying to work this out. Is there a common way to model these interfaces so that if we change it from a VF to a subfunction or subfunction to something else, is that something that OPI needs to define or not? So my thought was there's not a whole lot here, but there are some opens that potentially OPI in general, with whether it's lifecycle management or API, could kind of address potentially.
Okay.
And I
Okay,
think
makes
if we
sense.
want to do some code, then CNI shim that we were talking before, right? If OPI is something wants to implement in open source by itself and contribute that, then it's something that we can also work on, right?
Yeah, agreed.
So one more question, right? So we said DPU is its own host as an original definition of OPI early on, right? So do you see a host on the DPU also here, how it fits in? Are we here? Are there, in my head, I'm trying to think, are there two layers? There is one basic layer where some very, how do I say, physical and virtual network interfaces would come upon the host and DPU. And maybe that's the provisioning aspect of it. And on top, is there when Kubernetes comes in on top, is there another layer being built up, which is all virtual networking, CNIs, and it's another world, which a while back didn't exist. Suddenly, kind of, I look at it as a new layer on top. So maybe it's two questions. One is there a host connection on the DPU? And do we view here the whole thing as two layers? One is bring up physical virtual interfaces on host and DPU, and then a Kubernetes layer comes on top, and that is getting offloaded by this pink box here.
From a lifecycle management perspective, there'll almost certainly be a host layer and then a Kubernetes layer on top. The other way to view this is that if the DPU is considered to be an independent host, then you could either treat the host DPU pair as two separate nodes in the single Kubernetes control plane cluster, but with obviously different labeling so that different workloads go to them. Or you could separate the control planes, as we talked about before, for a pure infra control plane and tenant control plane being split from a security perspective. We kind of left all of that detail out of this because we wanted to focus just on the scenario of where functionality would run and what networking API we might need. But it's an area to drill into for sure.
Right. I think that one of the very next steps is to start talking about that, but we didn't want to confuse these drawings because they're already confusing enough with trying to add that type of next step on it as well.
Well, yeah, these are good. They're good drawings, and it begs my thought process on this is, if I read this, I'm seeing that I have, just to put it out there as VFs, I have VFs that are interconnecting either to the hosted network or to the pods. And then I have to have some entity that's going to do the deployment of the infrastructure networking pod, which is the CNI that's being pushed down, and do the configuration to set up those VF connections to those pods, which is going to use an API to do that initial provisioning and setup of all of that. The question that lays on top of that is after it's provisioned, do the services inside the pod need to do some sort of configuration of that virtual interface for their type of traffic or their type of flow, which would then say I need an API to allow that type of control from a user perspective versus an administrator perspective.
I would hope we can make this transparent from a pod's perspective. So
Okay.
anything that needs to happen would be encapsulated in that shim CNI we've spoken about so far.
Right. Yeah, that's why I was saying the shim CNI would be, but my thinking is that shim CNI that's below a pod would be what a user or a service would need to use to configure services within that connection.
But it seems like
Where
any
in-
service that's beyond the scope of the CNI is beyond the scope of this API as well, right?
Yeah, I mean, essentially anything beyond just providing the VF to a pod and the basic IP addressing for that pod will need to be done via listening to Kubernetes APIs for other things like services and policies and so on.
Right. I was going to, so the CNI itself is responsible for plumbing the interface into the pod. After that, like a typical Kubernetes deployment has a kube proxy, which handles your service. So if you want to create a service, it's going to say, okay, my service is backed by these pods. And then there's a load balancer to decide how to send the, if you want to send to a service, it decides which pod to go. And then some CNIs take that functionality of kubeproxy and then absorb it into a daemon set, which a lot of times is called their CNI, but it's kind of two sets of functionality. It's the CNI itself and the kubeproxy functionality. And then on top of that, you may want to add some policy that says, well, pod 5 can talk to pod 4, but pod 4 can't talk to pod 6. And now you have policy on top of that.
Right.
And so that part comes in through the Kube API. So, like Donald was saying, something's listening to the Kube API server to handle that policy. That all could be part of this pink box here called infrastructure networking. So we have the small CNI component of plumbing the VF into the pod, but you also have those other two components. And we generically put it in this pink box or a purple box or however you're seeing it right now. But that, I think that was the next level of detail on what those APIs look like.
Yeah, and I think we're already starting to ask around it because the diagrams are really driving out these types of questions, I think. So no, it's
where in this model is the kubelet that usually spawns the pod? Where is that executed in the host environment? And then
we don't want to tackle that quite yet. We do, because there's also I think that is the very next step, but there's also, when you start talking about that, you need to start deciding, are you running one cluster, two cluster? I think in general, kubelet, if you're going to be running pods on the host, you have to have kubelet on the host because it's a direct CNI call. It's not a messaging base. It's like a direct CNI call. So kubelet will be running on the host if you're running pod 4, 5, and 6 on the host. After that, whether we're doing one cluster, two cluster, and where other stuff lives starts getting very opinionated. And we wanted to stay out of that on phase 1 and just talk about, the different scenarios, and then drop into the next set of detail, which may be another slide deck, what kind of talks about where the different things like kubelet, and then how many, one cluster, two cluster, and how data gets flowing around Kubernetes.
So like if we can agree at a high level that these are the scenarios, we can start overlaying that kind of detail as the next step, which is exactly what Billy was saying. There's just one last thing I want to highlight here that I don't know if it's clear to everyone, but like we're calling it brownfield, but it's not pure brownfield, because even if you're talking about, offloading an existing CNI into the DPU or IPU, there's going to be some level of modification to that. Now, it's probably a lot less than the rest of the scenarios, but there is some work to be done there to integrate the whole thing into the big picture. I just wanted to highlight that point,
Yeah, that's true, Mariam, but we can expect to have users of today's CNIs use their current operations and APIs, whatever they are using with their CNI. That is the main goal, right? Preserve the APIs that CNIs are exposing and plumb it into DPU infra in a way that they don't have to change a whole lot. But certainly, the basic plumbing needs to change for sure.
Yeah, exactly.
Just as a time check, we've only got 3 minutes and there's 4 more scenarios, so I'm not quite sure how we want to proceed.
Yeah, good point.
I think what we should do is we should kind of close out with this scenario, and then I think next week we'll pick up and cover the other scenarios because yeah, we're not going to cover it in the next 3 minutes.
Well, that's a good plan, Mark, but that means that we're going to waste weekly meetings on going, slide by slide. We need to come up with a better plan, either to use more meetings or more try to work offline and not wait till this community meetings, because I'm not sure how many people here on the call actually read the presentation before the meeting. So somehow we need to be more efficient.
Or we could do it.
Just that at least making a first pass on not to spend too much time, just to at least to have a first pass in a call of the remaining slides, and perhaps more deep dive session on each of the scenario. But yeah.
Do people feel to free their time for another community call before our next Thursday, maybe early next week?
We could do it early next week if we need to.
And I think the other 4 scenarios, given the level of detail we talked to on that one, we might be able to cover in 10 or 15 minutes. But there'll be, on another meeting, there'll probably be a bit of recap, so factor that in as well.
We can use lifecycle group time if you want to for this kind of thing. Mark, let me know.
That would be good. If we want to do it in the life cycle meeting, we can cover
that Tuesday?
Do the other scenarios. Yeah, it's Tuesday, correct.
And it's interesting because it's bringing up some life cycle topics, so we can maybe take the time to actually discuss that as a follow-up during the life cycle meeting.
Yeah, I would support Boris on that. That's a good idea because many of us have that time blocked out already.
Yep.
That'll work for me too.
Go ahead and get it done quicker than longer. I agree.
Sure, sounds good.
Okay, I'll announce it in my group. Yeah, thanks.
Okay, thank you, Boris. All right, everyone. Appreciate it. It's a good discussion. It's a very good topic. And we'll continue in the life cycle meeting on Tuesday next week. And then beyond that, we'll continue in the API meeting a week from today. All right. Thank you, everyone.
Sounds good. Thank you.
Thanks, everyone.